I want to welcome everybody to our LINBIT Tech Days. This Tech Days features OpenNebula, and today we're going to be giving you a demonstration of DRBD and LINSTOR. Our presenters are Philip Reisner, who is the CEO and founder of LINBIT. I've had the pleasure of working with Phil for about 13 years now. He's the original developer of DRBD. It started as a university thesis project, I believe back in 2000, in 1999, 2000. And he developed a company around that, which is LINBIT. And LINBIT's been in business for about 21 years now. The other speaker is Renee, and Renee is responsible for LINSTOR and the plugins surrounding LINSTOR. So if you're using LINSTOR to plug into OpenNebula, for example, that's something that Renee has coded for us. Phil, do you want to go ahead and start with your demonstration?
Oh, it's Renee has the first part.
Pardon me.
Yeah.
Excuse me, Renee.
Yeah, sure. So hello, everyone. I will start with obviously LINSTOR, because that's what I know. So I will start with a quick overview of what is LINSTOR, or what components are there in LINSTOR. So, and this will be more from the technical side, because I am a developer, so I am technical. So you have actually three main parts, let's say. You have the LINSTOR controller, which is the mastermind of LINSTOR, which is deciding who it talks to, from what it gets messages, and relaying them, and doing all the algorithms to decide where to put resources and volumes on. It is it is written in Java, currently Java 8. It manages the satellites, as I said. It's using the protobuf for as protocol. Oops, don't click. It has persistent storage, so it stores every information it needs. So like on what node a satellite is, and IPs, what resources are there, and so on. It can store it in an H2 embedded Java database, or MariaDB, MySQL, PostgreSQL, and etcd. It has an REST API where plugins or our LINSTOR client are talking to the controller and give it commands to execute. As I said, then there are the satellite, or the satellites. It's usually more than one. These are on your storage nodes. So where you have storage or want to manage storage, it manages DRBD, LVM, ZFS, NVMe, and so on, OpenFlex. There are a lot of technologies, and it's getting more and more. Then you have, it retrieves all needed data from controller. So it's more or less not saving any data. So there is no storing backend behind there. So whenever a satellite goes online, and it gets connected from the controller and retrieves all information from the controller. And then there is the LINSTOR client, which is written in Python. And this is more or less just a command line wrapper for the REST API. So you don't have to put in curl commands to talk to the controller, and just enter it on the command line and get a bit help of it, and can create nodes, storage pools, and so on. So here is again a bit of an overview how the things are connected. So in the middle here you have the controller. Controller is usually, you only have one active controller. this is a requirement. So you can't have two LINSTOR controllers at the same time active. And the controller talks to the satellites. So a controller knows which satellites there are, and it connects to them and gives them all the information they need to do their work. And with the controller, you talk by the REST API, and this can be any connector we have. So now, as this is featured, OpenNebula talks to the LINSTOR controller basically directly over an Python API, which translates to REST API calls. Yeah, and all the other connectors. So then a short overview. I mean, overview is a bit exaggerated. We have objects in LINSTOR, like a node is an object, and storage pool is an object. Then the next high-level object would be resource groups, which, as its name is, it groups resources or resource definitions, but it's a bit of an internal detail. What are resource groups for? They help to have a group of resources which share the same properties or characteristics, let's say. So you could have a resource group which just plainly creates storage, layer storage, which is in LINSTOR terms, just an LVM, an LV volume, or an ZFS volume. Or if you want DRBD replication on it, it would create resources and use them. But this will be a bit clearer when I show you the demo, which I will start now. So we have, or I have prepared an LINSTOR cluster, which consists of 3 nodes. So we have LINBIT 1, Tech 1, 2, and 3. Right now, all of them are running the LINSTOR satellite. And just the number 1, or Tech 1, let's call it, is running the controller. And most of the time, we will only see the console from the Tech 1 node. So, as I said, we have here, this is the LINSTOR client. It also has an interactive mode. So you can, it's like an shell where you can easily type commands and get help about it and get auto completion. So right now we have no nodes configured here, and that's the first thing we will start to do. So we will add all the storage nodes, which in this case is all of them, because all have storage. I have created an volume group in LVM. It's called storage. And this storage volume group also has a fin pool in it. So we'll start with node create. And the node name. So we will call it like the host name is. And if it can be resolved, the host name, you don't even have to supply the IP address. So what you see now is, that LINSTOR obviously had success and registered this new node. The details are, just for additional information. And in the next response, you see what kind of supported storage provider this node has. So obviously diskless. Every LINSTOR node supports diskless for DRBD. Then LVM, LVM-fin, file and file-fin, and as OpenFlex target. And it also has layers. It supports layers DRBD, looks, write cache, cache, and storage. What it doesn't support is ZFS because I don't have any ZFS tools installed, so LINSTOR Satellite doesn't find them and can't use them for now. And the others are SDPK, which is a framework to use storage providers without running in the kernel to get better performance because of lock detention. And then we have also not supported NVMe and OpenFlex because the nodes just don't have it hardware-wise. Or in this case, it's in VM, but it also doesn't have NVMe or OpenFlex here. So now we'll just add the other two nodes. Output will be the same. You can see in the node list, LINSTOR has now 3 nodes, like 1, 2, 3, with these IP addresses, and they are online, which is good. So next thing you usually do if you set up a new LINSTOR cluster is add storage pools, because storage pools is what you need to get volumes for your use cases. Like if you want the volume for a virtual machine in an OpenNebula cluster, you need storage pools where the volumes are stored. So LINSTOR has storage pool list command, and you see there is already 3 diskless pools. So every LINSTOR satellite or LINSTOR node gets 1 diskless storage pool by default. This is always used if you have a DRBD node that needs diskless or has diskless. Phil will explain more what diskless nodes are. I mean, basically they are nodes that don't have the storage but can read from the provided non-physically existing storage. And now we are gonna create physical storage pools. In our case, the volume group from LVM storage, and then a second one, which is the fin volume group. So first, as I said, if you ever need help with the commands, you just type in a part of it, and then you will get a help output. And if you even need more help, you can -- help, and you get more or better help with more explanation of what each option do and what commands are available. So as I said, we want to have an LVM storage pool, and we need the node name, which is LINBIT tech. Then we need a name for the storage pool, which I will just call storage fat. And the driver pool name which is the name of the pool that is provided from the storage you have. Like in our case, this would be now storage, and ZFS, this would be the C pool name. So here it's storage. And it was created now on the LINSTOR controller, and you can see with list command, we now have a storage pool, storage fed on the node tech 1 with the driver LVM, and it's currently has a free capacity of 4.49 gigabyte and a total capacity of 5 gigabyte. The missing 500 megabytes are because of the fin pool, which we will add now. And for the fin pool, we just have to change basically the name of the provider or driver and the name of the pool. Let's call this storage fin, and the provided pool name, which is storage, and fin pool because it lives in the storage volume group storage. And it got also created. See, now we have two of them on node 1, one fed, one fin. And yeah, you see the fin has the ability to do snapshots. We decided to not allow fed LVM pools to have snapshots because the performance degradation is, let's say, if you have an LVM fed and you do snapshots on it, for every additional snapshot, you have an additional write if you change the data from the original data. So this performance degradation is very bad, and so we decided to not even support them. So now we'll add the same pools to the other nodes. And we're done setting up our storage pools for LINSTOR. So, and now we are back at resource groups. So, as we have kind of the same with default diskless storage pool, LINSTOR also has a default resource group. This is always used if you don't, let's say, you can create resource definitions by yourself, and they have to belong to some resource group. And so if you would create a resource group without options, it would be part of the default resource group. But in our case, we will create a new resource group. And you have the following options here. So a resource group can either use all storage pools, or you can restrict them to some defined storage pools. They have a replica count, which means in a DRBD environment that how many disk full or DRBD replicas you want to have that really have storage. And then you have some, I say, advanced options like do not place this resource when you create one, or we call it spawn, with another resource name, or even a regex, or maybe more common would be the replicas on same or replicas on different. So to explain that, you can have properties on pretty every object in LINSTOR. but I will show you for the nodes. I mean, there are some internal, and you can have auxiliary properties, which are user properties basically. So you could, let's say, put or define nodes on maybe their rec positions. So we can create an auxiliary property that would say, yeah, this node is on rec 1, the other node is also on rec 1, and then next nodes are on rec 2 too. And so you can, with a resource group, say then that all resources that are created in this resource group are on rec 1 or not on rec 2. And this is possible with resource groups and this replicas on same or replicas on different. So we will just now create a very basic resource group, which has a place count of 2. And we'll only use storage pool, storage fed. And we named it resource group demo group. So, and additionally, every resource group has a meta object that's called volume group, because in LINSTOR, resources have volumes, and they create a consistency group. So that means that a resource or volumes of a resource are always consistent. And for the resource groups, so you don't accidentally create more or less volumes, we added this volume group object, which just ensures that you not by accident would create for a resource group 5 volumes, but it only supports, or it's only meant to have 1 volume. And so we have to create 1 volume group for the resource group we just created. So this is how this looks then. So we have the demo group with a place count of 2, and using the storage pool storage fed here. So it, SDS indicates it could be, I could also have the list here in additional to storage fin, but I want the demo group just to use the storage fed, and it is allowed to have 1 volume. So, and now what can I do with this volume group? I can finally create resources or block devices from it. Per default, if there is no additional layer list, like it's in here, we work with the case of a DRBD volume. If you needed some NVMe, or you want just to create LV volumes, then you would need to provide the layer list with, let's say, storage. I mean, you can see the options here. So these are the options for the layer list: storage, NVMe, OpenFlex. But in our case, this is per default DRBD. And now we will use our resource group to finally create resources. So it's not resource create. It's called spawn. And you give it the resource group you want to use. And the resource definition name or resource name you want to have, like, let's call it demo resource. And the volume size. So I want a 300 megabyte resource. And now the controller decides on which 2 satellites it wants to create a diskful volume there. And from the output here, we see that we have created a demo resource on Tech 2 and Tech 1. And you can check that with resource list. That we have a demo resource on, as I said, 1 and 2, and they are healthy and up to date. And to see here are the final device names. So this def DRBD 1000 is what you would use if you want to write on it or create a file system, put that into your libvirt XML as a storage. And for example, we can now first check if it's really here, because I could lie to you and say, yeah, this doesn't exist, but it is here. And we could, for example, create a file system on it. So yeah, done. And we also have the same one on node 2. And I think my time is running out. So yeah, so what I wanted to show is how to set up quickly an basic LINSTOR cluster and define storage pools at the nodes. There are a lot more possibilities, so you can have different node network interfaces. So you can have the management communication on one interface and the real data net communication on another interface. But these are all a bit advanced stuff, but it's not easy to set up. It's easy to set up, sorry. And yeah, and this is the small how-to to get to your first resource, and all additional information you can get from our LINSTOR users guide for advanced steps and more possibilities. And I will now hand over to Phil.
Thank you, René. Thank you for taking us through that part. Then let me start. Oops. My screen sharing here, and here are the slides. I hope they're coming through.
Yeah, we can see them.
Then René gave us a very, very good overview and introduction of LINSTOR. And LINSTOR can manage DRBD devices. So let me dive into the details of what DRBD is. And let me start with this overview illustration. And it shows us 2 Linux systems, and this orange box here that gives us where the Linux kernel is, and the Linux kernel has its internals like a file file system, a buffer cache, etc. And on top of that, in user space, we quite often have our services running. Quite often, because sometimes we use the block device without a file system, then this part wouldn't be there. And maybe we use it for KVM, which is the typical use case in an OpenNebula cluster. And let's look at the rest of the stack. So here comes this DRBD virtual block device driver. And what it does is for write requests that come in, it duplicates them. So it sends them down the local stack to the local SSD or hard disk, and it sends it over the network all the way to the storage device on another node. And usually DRBD operates in synchronous mode, so it will wait until the write acknowledgement or the write completion event travels up the stack from the local storage device, and also all the way from the other node it travels back, and then it completes, then it signals write completion to the upper layers. What this illustration lacks is it doesn't show that DRBD can have multiple peers. And at that point, I will switch to the command line and let's dive into that. So I hope it's coming through now.
Yeah, we're good to go, Phil. We can see your terminals.
Perfect. Then let's see what Renee has left for me. And I'm showing here you the first command to inspect DRBD, and that's DRBD setup status. And what that gives us is, well, it gives us the resource name. It says, okay, currently on this node, you are secondary. The local replica you have here, that's up to date. It tells us that there is one peer, that's the node number 2. It's also secondary there, and it has a disk there that's up to date as well. And the node number 3, it's secondary and diskless. And it's a green diskless, that means is planned that it is diskless there. And so DRBD itself forms like a cluster, and it's like it's a cluster for this single DRBD resource. And with LINSTOR, you can manage many of these DRBD resources, and each of those DRBD resources are its own DRBD cluster. The DRBD clusters, they are limited in the number of nodes, so that can span only to 32, but LINSTOR itself can span to many nodes, so to hundreds or thousands of nodes. And a single LINSTOR instance can also manage like thousands or tens of thousands of those DRBD resources. Now, what can we do with such a thing? For example, let's make a file system on top of it. Oh, it's already there. I'm recreating it. And when we look at the status, it is still secondary. But what happened there is it was primary for a very short time. So let's mount it. And when we look at the status now we see here it is primary on this node. So with that, we defined the direction of replication. So it now replicates from node 1 to node 2 because node 1 is primary, node 2 is secondary. So we can create a file there. And now if we unmount it, it demoted to secondary automatically, and we can mount it somewhere else. So where's the mount command? Here it is. So obviously everybody expects that we have the file now here, and it is there, the file number 1. That's very basic. And oh yeah, let's look at the status again. Now we see here, the local node is secondary, the other one is primary. Now, another important thing that DRBD needs to do is it needs to resync if a node is away. So let's simulate that for a second. It's the demo resource. And now we create another file here. And just to explain that a little bit. So when we look at the DRBD status from the node 2, we see it's currently primary here. Yes, because we have it mounted. Node 1 is currently away because I took the DRBD resource down. You will see the same output if the whole host is down. It just indicates I don't have a connection to it right now, but I try to establish one. Also from the third node, it looks the same. And remember, we created file 2 here after we took this guy down. So the file 2 right now doesn't exist on the backing device of node 1. But let's bring it up again. And when we look at the status, it doesn't look spectacular. And we cannot see that a resync happened. So for that, we need to look into the log file for a second. And what happened here is it established a connection to this node 2. It went through this handshake. It decided that it needs to do a resync. It started the resync operation. Here it is. And it resynced 48 kilobytes in the process. And well, you might say, oh, that's a lot more than what is in the file, right? Because the file contains 0 bytes in it. So it has 0 byte user data. But the file system was writing more to its backend, right? Because it was writing to the file system journal that it's going to create a file. Then it created the directory entry and all these things, and that in sum is 12 modified 4K blocks, 48 kilobytes in sum. Okay, so it did that automatic resync. And now let's check that. Yes, as expected, it's here. So now let's quickly look at the diskless guy. So we can see here, it is diskless on this node. So it doesn't have a copy of the actual data, but we can still access it. So you see all the files are here. And what DRBD is doing when it is reading from a resource or from a device that's not locally available, it does what we call a read balancing. So it reads some block from node number 1, it reads some block from node number 2. When we write something here, then it sends the writes concurrently to both the other peers. So then let's do something different. These were very basic operations so far. Now let's look at something else. Let's examine the quorum behavior for a second. For that, let me unmount it here. I mount it here again. And now let's isolate node number 1 from the other 2. It's called demo resource. And here's my typo. Okay. Okay. And you know, I did this disconnects in this particular order to have here a node that is still up to date, but it has no peer. So one says standalone, one says connecting, but in both cases it's red. So that means something else than the connection is established. So what you can notice immediately here, it says quorum no, but up to date. And here on this guy, we still have everything nice. It is still primary and it has one peer. So what we experience here is that LINSTOR enabled quorum in this DRBD resource. That means a pair of, and it is a DRBD resource of 3 nodes. And the majority of 3 is, well, 2 is still a partition with majority, and a single guy is less than the majority, the minority. And the partition that has less than half the nodes has lost quorum, so it will disallow us to modify the data. Let's try that. Okay, and the mount even gives us a readable error, but to make that more apparent, here the error message is very clear. You need to be a partition of 2 nodes in order to promote this guy. Yeah, and yeah, next steps, if I would reconnect them, everything would continue. And maybe the next steps we could take here is that we completely isolate this primary and So now this guy lost quorum, although the file system is mounted. So let's create another file here. I think file number 3 is the next one. And here we get the error message from the file system. Because DRBD DRBD now issues only errors to the file system. Okay, so writing file number 3 didn't work out because this guy lost quorum. Now let's restore these two guys. And status. Okay, now node number 3 is connected to node number 1 again. So these, yeah, and they don't regain quorum because one of them is diskless. Okay, before I lose myself in the details, let's switch back to the slide deck and let me go over a few things that I want you to take away from this session. So why is DRBD and LINBIT SDS a good choice when it comes to speed? It is since the DRBD kernel data path is completely in kernel. We don't leverage on any userland daemons for that. We lay out the replicas at allocation time. When we do I/O, everybody knows where these I/Os goes to. It's building on existing components, as you know, LVM, CFS, looks, video, etc. So everything your operating team learned in the past, they can reuse that knowledge when running a LINSTOR or LINBIT SDS cluster. And since DRBD and LINSTOR use so little resources on your machines, it is very well suited to be used in a hyper-converged way. And this is also very well true for OpenNebula clusters. So when we look at it from a point of view of a workload, when is it a fit? Any kind of online transaction processing, also for analytics processing, persistent containers for persistent volumes for containers, and virtual disks for virtualization, of course. Okay, this was what I wanted to show you, and I think I have nearly no time left.
Pushing the limits, just like DRBD. So if there's any questions, please feel free to ask them either in the chat or the Q&A option on Zoom. We do have a couple more webinars coming up. We've got the next one at 9 o'clock that goes over, I think, the deployment of LINSTOR and OpenNebula. So LINBIT SDS and OpenNebula. So Renee will be on that one as well. So if you'd like to join that, please feel free to do so. Looks like Neil's just posted the link in the chat. So we've got that. We can hang out for another 5 minutes or so to answer any questions you guys might have. Just to provide a little bit more information while we wait for questions, if there are any more. The third, so we've got 2 more webinars for today. One is the OpenNebula one that I just mentioned, and then we have the Supermicro presentation, and they're going to do a little bit of deep dive into the hardware side of things, where you might use LINSTOR to build yourself a cluster. And then tomorrow we have a presentation from OpenNebula about OpenNebula 6. And we've got a customer success story from I'm going to butcher this. Procolix, I think is how you say. I don't know how you say that. Phil, can you help me?
You did it. You did it perfectly.
Okay. Most of the time I'm horrible at enunciating those things. And then we've got the developer Q&A, which is going to be my favorite session, I think, where we get the real meat of the subject matter and all the tough questions come through. We get to talk to the developers. Okay, so we do have a question from Robert Isaacs. We'll go ahead and answer that live just because we're here and we have some time to kill. It says, is quorum still helpful when you are not in a multi-master write scenario? Say in a virtualization scenario where only one machine will ever access the DRBD resource?
Yes, very good question. Yeah, quorum is always helpful. So even if we only have a single writer and one or two secondaries, the problem you might run into one day is that you have network separation. And if it falls apart into one node and two nodes, or maybe in three isolated one node partitions, then quorum guarantees that you cannot maneuver yourself into a so-called split brain situation. And when you look on the net about the problems people had in the past with DRBD clusters, it was always related to this so-called split brain problems. And quorum is like the ultimate solution to that, because it only allows the user, KVM or whatever, to modify the data set if the partition is the majority of the cluster. And that will save you in the real world scenarios, in the real world failure state. There is a lot of detail to consider, like the last man standing aspect of it, like the aspect how a diskless resource counts in the quorum algorithm, and what to do if you lose quorum. And the two basic choices are either DRBD throws IO errors, which will stop the former primary, or that you freeze IO, and that allows you that everything continues to run when the switch returns its service. But the whole discussion is probably a little too long for this answer.
Yeah, unfortunately, we've got to shut her down. We've got the next webinar coming up. Feel free to join that one if you will. I think Neil's linked that in the chat, and we can continue this conversation there. Thank you all for attending.